All right. Good morning, everyone, to our second and final module of our Analyzing Data for Racial Equity series. For those just joining, you should have received a link to the slides in the email I sent about 5 minutes ago. Get yourself set up, whatever that means to you. We recommend closing your email. If you're willing and comfortable and able, turning on your camera so we can see your amazing faces. Get your R studio set up, and I'm gonna repaste some imports to run in your R session that aren't shown in the slides. Added that to the chat. And as a reminder, as we go through the slides and you see the code, you can copy the code from the slides with the little clipboard in the upper right-hand corner. I think that's all for logistics. Yes, there's a GitHub repo. We will share a link to it at the end of the session today. Okay, I think with that, let's dive in. Hannah, take it away. Thanks.
Yeah, absolutely. Hey, everybody. Thanks so much for committing to spend another couple of hours hanging out this week. I was really excited by last week, where we left our analysis last week, and excited to get back into it with you. As a reminder, if anyone is watching this video in the future that maybe didn't watch the first one, I'm Hannah. I'm a partner at DataMade. We're a small data and web consultancy based in Chicago, but do work all over the place. And I've worked with the water boards for a few years now on different data tasks. Most recently, just data equity data coaching. And yeah, spare time, chasing my toddler, riding my bike, knitting everything. So without further ado, we can get into it. I think same as last week, Anna will kind of keep an eye out for like raised hands or questions in the chat, but there will be some places where we'll stop, have some time to chat as a group. So we'll kind of address things as they come up while trying to kind of consolidate the discussion where it makes sense. Cool. So we'll start this week with a quick recap of last week. First, to reestablish our working definitions, racial equity is a practice, not a destination. It is something that we can refine by working on it, looking at the results, and kind of changing this or that thing and seeing, if that affects the results positively. So if equity is a practice, then racial inequity is a difference or disparity in the quality of service or access to resources. And we're interested in disparities because they can represent injustice, and figuring out kind of what is the core of that injustice can help us understand where, like what solutions are going to be effective in addressing, mitigating that injustice. And also it'll help us think about think about other places where that same mechanism might be at work and so might benefit from some of the same interventions we're contemplating for our original area of analysis, or original focus. We're going back to Lamont, or I guess we'll go back to Lamont just to discuss what we found. So Lamont got 25 million from Safer to fix their drinking water system in 2023 or 4. And their system included 3 wells with high levels of arsenic and 1,2,3-trichloropropane. In our analysis, we found that people living in the city center of Lamont are more likely to use public water, and that those people in Lamont were more likely to be Hispanic in origin. So we found that like Lamont is a heavily Hispanic population. So we've got, a factor of disproportionate exposure there, but also because of the population dynamics, a higher proportion of the Hispanic population was also exposed or was exposed to the contaminants through public water use. So we also know, and I'm just going to reiterate this because this is what we're really going to dive into today. So in our linked press release here at the bottom, we know that There were three 45-year-old wells in the failing water system that exceeded the MCL for arsenic and trichloropropane. There's a bit more. I think there's some familiarity with trichloropropane among the group because people were talking about it last week. But if you are not, this link here at the bottom to just some details about what it is and where it comes from might be useful to you. So that's what we covered last week. This week, we're going to think more about that second facet of analysis, right? The mechanism. What is really kind of contributing to like the failing water system in Lamont? And is that at play in other places? So to do that, we're going to use a technique called root cause analysis. Anna has put together a really excellent resource in the handbook that goes really deep into what a root cause analysis is and sort of some framing for how to conduct one. There are some few key considerations that you should bear in mind when you're doing one that we're kind of going to gloss over today for the sake of getting straight into the data, but I think they really bear repeating. So first, when you're doing a root cause analysis, it can be really tempting to kind of do it internally. It's scary to kind of be in a vulnerable place where like you might be part of the root cause of a problem, right? But it's really important to not just have it be you or your team or the water boards. It should really include community partners too, because as we discussed last week, data aren't people. Data aren't lived experiences, and having those perspectives is going to be really crucial to making sure you understand like the constellation of things that contribute to a problem occurring. You also want to make sure that you've allocated enough time for your analysis to be thoughtful and also continue to ask why, right? Like I think one of the mantras of a root cause analysis is you need to ask why 5 times, you're really kind of digging down into what are all the layers of things going on here. And so if you've only set yourself an hour, you may wind up with 10 questions and not a whole lot of answers. So you want to make sure you allocate enough time to chase the rabbit down the hole. And then you also want to be prepared to honor hard truths. So like I mentioned before, we know that institutional racism is a thing. We know that, the government has behaved differently 10, 25, 50, 150 years ago than we might behave today. And so it's important to be able to kind of be good with that and address that more less from a point of man, we really messed up, and more from a point of view of oh man, we could really change this now and help ameliorate some of the harms that we caused. So with all of that in mind, what we're really going to focus on today is just kind of thinking through what's going on here? Why is that happening? What's going on there? Why is that happening? And kind of pursuing that down. And I really liked these diagrams that are in the handbook. And so I wanted to show them for our visual thinkers. Let me see if I can zoom in here a little bit. No, not really. Okay, but if you've got the slides open in front of you, there's lots of ways you can go about thinking about this. This A prompt just kind of goes through that cycle of why is something happening? Here's the answer. Why is that thing happening? Here's the answer. Why is that thing happening? It's a linear progression. I like this B because it has a number of sort of prompting questions that can kind of get your mind working in a more holistic way than just because we know it's not just usually a linear chain of events. There's lots of things happening all the time. So we have why did this specific issue occur? And then you kind of dig into why it happened. Why did nobody notice it? And you dig into that. Why was it not prevented? And dig into that. And then you can start to think about the interplay of those things and really get at what's going on here. And then C goes even more into the Spider-Verse here. So I think there's sort of a framing for lots of minds here. I'm partial to B myself, but I wanted to give you these examples so that you can choose the one that kind of makes most sense for your brain and or the issue at hand. I did want to leave a little space since Anna kind of wrote the book on this. Are there other points about this like root cause analysis process that you wanted to highlight for the group?
Yeah, I would say that I assembled the book, but it was written by many others. um, I think the key here is that the the root cause analysis can go by many, many names, and there's lots of variations of the root cause analysis. The key point is that the thread that like runs through all of them is you ask why a lot, at least 3 times, usually closer to 5 or 6 times, so that it prevents us from being like, well, why is this thing happening? Oh, it's for this reason. And that's like the symptom, not the cause, right? So there's links in the handbook where folks can go into more detail. And these are examples of ways others have conducted the root cause analysis, but it's not like the only way that it can be done. So I'll just, I guess, leave it there. Oh, you're muted.
Um,
Mass
I was just
exam.
saying to underscore that point, you're now going to get the chance to start to get your brain into a root cause analysis place. So we're going to start instead of end with breakout rooms today. We're going to have you guys take 10 minutes to discuss the root causes or potential root causes of the contaminated water in Lamont and how folks were exposed to it. I have some framing questions here. So like, how are people exposed to contaminated water? How did the contaminants get into the water? Why hadn't they been removed previously? Those are just examples. So if there are other facets of this problem that you all want to discuss in your groups, I welcome that. There's a link here on this slide to the press release that has more information about Lamont and just like the safer funding decision and actions taken in general for extra context if you want it. And then like last week, we'll have a representative from each group share a quick summary of what they talked about in their groups when we reconvene. Um, yeah, I think Anna, if you want to.
Yeah, so I'm going to open the rooms in a second. You'll be with 3 to 4 other folks. Just to recap, you'll have 10 minutes. Just like last time, pick a representative to report out first so that that's over and done with. You'll get a 60-second warning when the room is going to close, and we'll see you back here in 10 minutes. Any questions before you dive in? Okay, great. Warm up those voice boxes. We'll see you in 10 minutes. All right. Welcome back, everyone. Look at that. Cameras are on. I love it. Okay, so just like last time, I'm going to ask the room sharer outer reporter representative person to raise your hand using the reactions button. Awesome. I'm looking for 5 hands. Great, great. Uh-huh. Okay. Um, Lily, do you want to go first?
Sure, I can go first.
Just sorry, I should tell you what I'm asking you to do. Just a couple of notes, a couple of thoughts, a reflection for your breakout room, like 1 or 2 minutes. So we can go through. So maybe walk us through like one of the questions that you discussed together.
Okay. Um, so I feel like we kind of quickly deduced that drinking water was probably how people are being exposed. And the contaminant, like how contaminants got in the water. In the press release it says like the area was composed of mainly agricultural workers. So the pollutants in the water, in the drinking water, probably from agricultural runoff, like TCP is usually one of those. I think the other one was arsenic. I can't really remember, but most likely agricultural runoff. And if it's groundwater, then it's just um, seeping into the groundwater. And then we talked about reasons why the contaminants hadn't been addressed in the drinking water. I think one big one that we touched on was potentially environmental justice concerns, lack of funding, if it's predominantly agricultural workers and maybe Latino population, there might not be a lot of money that was being invested into the community. Also, if anyone was aware of the pollutants that were in the drinking water, maybe the population was kind of aware that something was wrong with the water, but the local government or whoever might have not been really paying attention to it. And
Awesome.
yeah, so.
Thanks, Lily.
Sure.
Bobby, do you want to go next?
Sure. Here. So a couple of key points that came out of our discussion with how people are exposed to contaminated water was likely through drinking water sources. We also had a question come up in consideration of whether how the contaminants were measured, whether it was from the well specifically or if it was from the larger water system. A couple of folks in our group were familiar with the TCP as a industrial solvent for degreasing mostly, so it could have been from some sort of process that needed it for cleaning. And regards to the contaminants, we also discussed perhaps maybe not just looking into current industries in the community, but also historical ones as well that might be contaminating in a warehouse somewhere in the area. So there's some bigger points that came out of our chat.
Nice. Thanks, Bobby. Luke.
Hi, everyone. So our discussion was very similar, but to maybe put our own twist on things, we focused on the timeline. We kind of pieced together a timeline of what happened to help us understand a little bit better. So TCP was likely applied in the 1950s when there was probably zero regulation whatsoever when it came to agricultural chemicals. And TCP is a chemical that just sticks around for a very long time, if not forever. And we learned that most of those wells were dug in the 1980s. So there might not have been the capability to test for those chemicals. And it's also highly doubtful that anybody was going to look for those chemicals just based on the demographics of the community. A working class Latino agricultural community wasn't likely getting looked out for back in those days. And we also learned that the maximum contaminant level for TCP wasn't established till 2017. So it really just seems like this is a chemical that's it's garnered some attention, but clearly not enough over the years. So 2017 is very recent and doesn't look like this was the highest priority for anyone. So yeah, I'll wrap it up there. Thanks.
Thanks, Luke. Selena.
Are we just focusing still on the first question? How are people being exposed, or just kind of
Follow your heart?
okay? Okay. We kind of talked about the root cause analysis, like, starting broad, like what is the problem, and people are being exposed to contaminants in their drinking water and probably showering in it as well. So why is that? Why is that particular group being exposed? Probably as an outcome of redlining. Typically BIPOC communities are adjacent or in mixed use, ag use, land use, mixed industrial use, that kind of thing. And also proximity to agricultural or farm labor jobs. And, why hadn't the contaminants been addressed is, probably cost and all the other things people said too. And it's expensive to treat and filter for TCP. And then we also kind of discussed, how the contaminants may have gotten in the water. It's, kind of, those contaminants are indicative of, as was mentioned, industrial solvents and agricultural land use. So going
Great.
last has kind of already been said.
Yeah, no, you're good. That was great. Thanks, Selena. Patty, take us home.
Yeah, so we were a group that we didn't really have a huge grasp of the contaminant itself. So we did a little bit of searching first to get an idea of what are the problems, what is the persistence in the environment, etc. So we looked at assuming the exposure similarly was largely through drinking water, and looking at the land use in the area and making the assumption agriculture is largely the source. We looked a little bit more into contaminants, why hadn't they been removed from the water? And beyond just the inequity issues that can stem in an agricultural setting, we were also thinking that perhaps the actual treatment method for removal is not easy. And so it's not simply just like run it through your water treatment system. So that was sort of our conclusion as to potentially why it hadn't been removed from the water source.
Great. Thanks, y'all.
Mhm.
Nice work for a 10-minute root cause analysis. Y'all kind of like found lots of different paths forward in terms of where we go from here to begin to solve the problem. I'll pass it back to you, Hannah, to share any reflections or move on into the next part of the training.
Yeah, for sure. I love how all the groups sort of together, zoomed out, starting back in the 50s and kind of the historical timeline to how we got here. And then, talking more about the current reality or more recent history too is like super, super great. I feel like sometimes it can feel like, oh, I'm really shaving the yak here. I'm really kind of off base here. If you're thinking about what's going on in the 1950s, but I feel like that means you're probably doing the right or a right kind of root cause analysis, which is super. Yeah, so we'll just walk through like a couple of quick answers. You guys were very thorough and like very on base here. So how are people exposed? We talked about drinking water, the public water use, bathing. Why do people live where they live? The redlining, proximity to work, both of those came up. Also potentially like tribal lands, although probably not in like Kern County. For these points, like I did want to kind of call out, like they're an important factor, but most of them are, especially like population dynamics where folks live where they live, not necessarily one like a lever that the water boards can easily pull. But if this was something, that you found to be very strongly related to the failing water system thing, it would be a great opportunity to identify some partners, whether that is other institutions or community partners or just residents. It'd be a great way to bring in those other perspectives to kind of, not just address the water shape parts of the problem, but actually like the problem in a more holistic way. A couple of answers for how do contaminants get into the water. So age of wells, which we all talked about, a concentration of ag activity, which we talked about. Also like the inclusion of the industrial solvent vector for getting into the water. And then why hadn't they been removed? I think we touched on a lot of these too. So could be permitting, could be cooperation. You may have noticed in the press release that it was a water system consolidation. So in addition to kind of replacing Lamont, they also brought, I think it was an unincorporated part of Kern County along with them into this new consolidated system. I think there's even a quote in the press release that's like, what an amazing feat to get two people like or two places working together. So that, and then limited resources, which is called out by almost everybody, and is actually the lever that SAFER pulls by offering monetary subsidies to mitigate some of these failing systems. So yeah, there's definitely a number of factors, a number of facets and a number of factors of this. And so we're gonna dive into one of them as a way to come and kind of demonstrate how, like, if you have identified a mechanism, you can use that to kind of scale the intervention that you come up with to places that where that mechanism may also be in place. So we've got a couple of like bell ringers here to transition us into this section. If you read through the press release, you might notice that there are not just one in Lamont, but 15 water system consolidation projects in Kern County where Lamont is located, which is about 16% of the consolidation statewide. So there's like a big concentration of safer funded water system consolidations happening here in Kern County. Some of this may overlap with the discussion you just had in your breakout groups, but like clearly there's something going on here. What could be like a common factor like in Kern County that could cause such like a widespread occurrence of failing water systems? And that could be at play in other places around the state. This is where you'll be prompted. You can drop your ideas in the chat and Anna will read them out, or feel free to come off mute and you can just chime in for the group.
Most of Kern County has a problem with 123 TCP. I live in Kern, so I know firsthand. The whole county is.
Thanks. We have someone in the chat that said lots of agriculture and lots of disadvantaged communities, and they wonder how much of the water comes from groundwater versus surface water. Anything else? Common factors? Feel free to unmute yourself.
I was just thinking about when we talk about groundwater, and it looks like, especially with the TCP, that drilling can cause an increase in the, I guess, availability of that toxicant. And so Kern County has a lot of oil and gas drilling. So I'm wondering if that probably has an impact on it as well. Just a lot of ground disturbance.
Yeah, thanks. Someone else in the chat basically plus one that comment. Other folks said dropping groundwater levels and the need to always dig deeper wells. Salty soil complicates groundwater things, ag, oil, all great things. Let's keep moving.
Totally. Yeah, that's really excellent. Cool. And so among many factors we discussed, agricultural activity came up quite often. So we're going to kind of zoom in there and use that to walk through some of our coding examples here. But before we do that, we have some data pre-canned for this, but I'm curious if you all have some ideas of what data is out there that could help us understand the relationship between agriculture and water system health. Just we're looking for kind of like data sources and maybe like a thing or two about like what relationship you would expect to see and kind of how you would approach this question of is ag and water system health related on your own. Again, we're going to chime in or share your ideas in the chat.
Yeah, promptly someone said gamma data and would expect more nitrate in groundwater in agricultural areas. National land cover database, land use data, maybe look at the correlation between ag land use and water quality. Nice. What else? Maybe in your breakout rooms, you might have discussed potential data sources, irrigated lands, regulatory program data in CEDN, groundwater data, Sigma data. Awesome. And much more.
And much more. Yeah, I love hear all of these like super ideas. I'm just like hearing all the ideas and being like, oh man, this example is like pretty basic, but like it's great because you can use these principles to go into some of this more granular or specific data and really dig in, whether it's this question or another. But what we're gonna look at today is the pesticide use layer from the Callan-Byers screen map. And then we're actually going to use the safer funding data. So since we're interested, or the safer risk analysis data, so since we're interested in like the kind of yes, no of is the water system failing, we'll use that data to get that information about all the water systems in the state. And then we'll use the Calum Bioscreen data to look at the track level of like the intensity of pesticide use. So before we get into those things, I wanted to share a few notes on mapping, because we'll do some statistical analysis, but we're mainly going to be making a lot of maps today. And so I wanted to foreground that with just some notes. So first of all, if you've worked with maps, you've probably heard of projections. If you haven't, welcome to yet another world of acronyms and numbers and things that you're going to have to like remember. Somehow it can really look like alphabet soup, which you'll see on the next slide. But basically, projections exist because maps are flat and the Earth is not, allegedly. No, just joking. So a projection determines how your mapping software is going to like translate the Earth's curvature into a flat map. You can see down on the bottom here this example of like different projections applied to the United States. And so as you can imagine, you know, if you've projected one data set this way and another data set that way, you're not going to overlay cleanly. And in fact, it's like not a valid way to analyze data in a spatial way. You'll get incorrect results. So it's nice because a lot of software, including R, will break basically if you ask it to do some sort of join or some other kind of analysis with different map layers that are in different projections. So know that you do have that kind of safety net. Like I think most mapping software will flag that problem for you. But it's also something to be aware of because sometimes that error is not necessarily very straightforward. And if you're debugging mapping code that's like failing to compile, or you're getting weird results like in a user, like a graphical interface, that projection might be something that you want to check. So there are a few like projections that are helpful to know for doing work around California. I would be actually really interested if there are other ones that folks use often, but just in general, 4326 is kind of the global standard for doing latitude, longitude points, so point data. California Albers equal area is great for statewide analysis of California. And then there is a plane coordinate system that can be more precise if you're looking at like a particular region of California. So on this slide, each of these will link to ESPG, EPSG. I get that mixed up. You can see it's wrong on the slide in a couple spots. .io, but it's a really nice resource that kind of tells you what different projections are good for and also gives you like a map of like what area they're good to use for analysis for. Let's see. And Anna shared in the chat, there's a really nice resource on in the equity data handbook. But I think like the general rule of thumb that's going to come up in this example is that we're doing a statewide analysis, so we're kind of going to default to 3310, but we are going to do a few like point mapping exercises too. And if we're just using like the lat long, then 4326 is our guy. So that's projections. I also wanted to make a quick note about accessibility, which is that accessibility is part of equity, right? Like we want to make sure that whoever's looking at this or otherwise consuming this can understand what we're trying to communicate, right? So for mapping and visuals in particular, color blindness is a really important consideration. For mapping, this resource Color Brewer exists, which is great. It's just a website you can go to, and then it has color schemes that you can filter for like colorblind friendliness or like other vision impairment friendliness. And you can also choose between different types of scales. So you can have like a sequential, like increasing like spectrum. You can have like a diverging thing. So maybe you have positive and negative values, or you can have a qualitative scale. So if you're mapping like categorical data where it's not necessarily values, but it's like failing or not failing, it's got great ones you can kind of grab and go. You can say how many like colors you want. It's a nice tool that you can just use in your browser. So it's super easy if you're working in like a, you know, ArcGIS or a point and click type of situation rather than an R. And then in R, there's some nice convenience functions from ggplot that will give you accessible color scales. So the Color Brewer scales can actually be kind of automatically accessed through ggplot with there's a few different methods, but they're all lumped under this like scale brewer documentation. But it's basically a wrapper or a way that you can get a handle on some of these like nice to use color scales without having to manually define them yourself. We'll go through a few examples of how to use that. One caveat there is that like the particular ones that were built into R were made for discrete scales. So these are like counts of things, and they have like a your mileage will vary disclaimer if you want to use them for a continuous scale, which is more like a measurement. But if you do have a continuous scale and you want something a little bit more foolproof, I would point you to the Viridis color scales, which are really nice. They're kind of more optimized for like highlighting like differences. So you can see the default one is kind of like this blue to yellow heat map. But this is also a really good option. It's a little bit more flexible in terms of the type of data you can use it on. And you can get at it the same way you would the Brewer scales, just with your little convenience function. So I don't think we use any of these today, but the documentation is linked in the slide. So, and it follows kind of the same pattern as the Brewer color scale functions. And then finally, this is under vision impairment, but it's also just like for the sake of being thorough and the sake of being understood as broadly as possible. But this came from a place of like, not everyone can see a map, right? And so it's really helpful to have a data table or summary text or something that a screen reader can use. But also not everybody is able to interpret a map as they are a table or vice versa, or Anna pointed out, some days the map's just not it for me. I really need a paragraph. And so it can be really helpful and really contribute to kind of a broader understanding of what you're trying to say, to have these complementary ways of presenting the same information. It's often like redundancy in like different visual types is not bad. It's good. It's just like a way of making sure that you're presenting the information in a way that's going to be understood by as many people as possible.
Can I add another point here before we move on?
Yeah.
I just want to note that a lot of us were trained to like get the data, get the figures out really fast. And so taking time to go through all of these considerations and add the additional documentation or the data tables or whatever, like it's not nothing. And so one of the ways of integrating the equity lens into our data intensive work is to really understand that doing all of this is more work. It takes more time, but it's also like the baseline part of our job. We should be doing this anyway. We know better, so we should do better, right? So just like factor that in when your supervisor says, hey, how long is it going to take you to do this map? Yeah, you could throw one together in 5 minutes. Will it be the best map you've ever made? Will it be accessible? No. So maybe like give yourself a little bit more time to create things well instead of fast.
Yeah, for sure. And to that end too, it can be really helpful to get another pair of eyes on something. Like, so maybe your supervisor's like, how fast do you get me this map? And you're like, well, I take like 2 hours to put together something good. And then like maybe you could take, 20 minutes and look at it and give me some feedback and make sure that I'm being legible to someone who's not me. And then maybe another hour to revise based on what you have to say. But I would definitely recommend, like, I think working like in community and getting other people's input on like what works and what doesn't is super, super useful. And it can, we've all got blind spots, speaking of vision impairment, but metaphorically visually impaired. So it's good to get other people's perspectives and leave time to incorporate those perspectives, especially if it's a public facing thing or something that you like are really using to communicate with a broader audience than just your immediate, team. Right. Cool. So that's like our notes on accessibility. And then I just wanted to run through a quick list of pros and cons of some of the mapping types that we looked at this week or will looked at last week or will look at this week. So point maps, you've all seen them as dots on a map. They're good for communicating the precise location of things, but they can be kind of illegible after you get above a certain number of points. If you're making an interactive map too, performance can be a consideration as well. So if you've got 5,000 points, like your browser, whatever you're using to view your map might start running slower just because of all of the points that you've got. Dot density that we made last week, if you remember, the population maps are really good for communicating like approximate distribution of a particular phenomenon. But they are imprecise, and you kind of have to have a sweet spot of data, too few points, or if the distribution doesn't really vary, they don't work super great. And similarly, if you've got a bunch of points, then you just have a massive black. And so in this case too, it's not just a function of the number of points you have, but also the size of your geographies. So if we're doing like tiny geographies, like a census block or something like that, like might not always be a great choice for dot density maps because you just have like a tiny space to put your dots into. So if you're trying to map a big number in there, it's not really going to show up.
And then, sorry, another thing to add to this, I just wanted to flip our lens on this as well, thinking about accessibility, privacy, data sovereignty. Sometimes very precise points are not a good thing in our data storytelling, right? Because then we expose information that we shouldn't be. And so really like thinking about who our audience is, who's going to be impacted by our visualization or our communication. That's also another way to think about these pros and cons is maybe point data when thinking about something that's highly sensitive and exposing to communities. The con is that point data is highly precise. So maybe a dot density map is a better option to communicate what you need to communicate while protecting some privacy and sovereignty around the data that's representing the people in that community. So just wanting to like flip the lens as well there before we keep going.
I love that point too, Anna, because it's like privacy of an individual, but could also be, like the reputation of a community, like plotting things like tells a story about a thing, and you want to make sure you're telling the story you need to tell without creating undue harm in the way that you're telling it. So I'm glad you flagged that too, because it can be at the individual level, but you could also be creating or reinforcing like a negative perception that maybe isn't necessary to like what you're trying to communicate. Super. And then like the last map type we call out here is the Core Plus. So we made one of these last week too. If you remember, we colored the census blocks based on the probability that a resident would be using the public water system. They're really nice for also communicating approximate distribution. Another like pro of these is you can distill large values into kind of a legible and comparable thing for a bunch of geographies. One thing that's pretty tough here is that they can be difficult to layer. So usually with a choropleth, you have one color scale. You can make what's called a bivariate choropleth map, where you have two variables that are color encoded. So you might have like a red variable and a blue variable on an axis, and where they're both high, they get more purple. But that can be pretty difficult to read, and so it should be used sparingly. There are some pretty cool maps that have been made that way, but it wouldn't be my first choice usually.
Yeah, we've got a
yeah.
question. Danya?
Yes, thank you. So I'm sorry, I think I kind of missed it. What was the recommendation if, let's say you're trying to emphasize that a community needs drinking water consolidation, wastewater consolidation, because they have very well documented nitrate contamination in the groundwater, and so you are trying to show where the heat areas are and everything, but without kind of killing any real estate possibilities for the entire community. So how do you kind of accomplish both goals?
I think the short answer, and I'm going to keep us to the short answer for now. We can circle back at the end to dive deeper once we've like gone through the materials, because I think that'll give some inspiration. The short answer is the most unsatisfying, and it depends. It depends on the data you're using. It depends on your audience. It depends on like what you want to communicate. And it'll be a combination of tools in your toolkit. So if you could hold your question, maybe put it in the chat so we can circle back to it because it's important. Let's dive deeper once we've gone through some more of the material, because I think that'll help.
Totally. Amazing. So on that note, we will start out by making some maps of pesticide use. So like I mentioned, we're going to use the Calendar screen indicator layer for pesticide use to look at patterns of how and the intensity of pesticide use across the state. Quick couple notes on why we're going to use this data source. And this is a great practice to get into because as you may have noticed when we were talking about it as a group, there are a lot of different data sources that you could use. And it's good to like have a reason for using the one that you choose. That reason could be it's most easily accessible. That's fine, but it's good to like think about it and justify it at least for yourself before you get started so that you can make sure you're using the one that makes most sense for your question and your working reality. So why Calendar screen? We know that pesticide use, it's not like farming. The act of farming itself doesn't introduce the contaminants. It's the pesticide use specifically. So that helps us get a little bit more, a little bit closer to like the actual cause of the contamination. And then Calendar screen does a lot of pre-processing for us that we can kind of build on top of instead of having to do a lot of that ourselves. So they already apply or they choose like the most hazardous and or volatile pesticide ingredients to analyze. It comes with percentiles already calculated, so we can have like a ranked list basically of where the most intense pesticide use is happening, and that can be really useful for like when you've got a bunch like values that could really range between different places. And then it also includes population characteristics like race, ethnicity, median household income, things like that. Plus all of the other indicators that are available in Calendar screen. They're all in one data set. So you could do a more detailed analysis either by looking at the interplay of different indicators or bringing in some of those population characteristics, and it's all already there for you, which is super from a trusted source. Down at the bottom on this slide, you'll see there's a page on the tribal water data map layer guide about the agricultural pesticides and a bunch of other Calendar screen data as well. There's also a link here to the methodology from Calendar screen that goes directly to the pesticide use page. But this methodology, and if anybody on this call is involved in writing up this methodology and working on Calendar screen, so good. It's a great resource. And it's a super example of like, if you're doing a data release, like how you can document it to make it easy to use for other folks. Cool. So, welcome. We're an hour in. We're going to start writing some code now. So the first thing we're going to do is just get our data from Calendar screen. So there's a link down at the bottom of your slide actually where you can download this data. And then you'll want to drop that zip file into the data raw directory. This, if you're coding along, it might be easier to pull the GitHub repository down. So if you want to wait until that's available after the call, might be a little bit easier to work with. But anyway, we're basically taking the zip file that you get and expanding it. And then we are extracting the shapefile, or yeah, we're getting the file path to the shapefile. Which is like the geographic data file if you're not familiar with the file format. And then we're going to use the read SF method from the SF library to read in our shapefile. It's as simple as passing your file path to the read SF function. And then we are going to work with our map projection in mind. So we're doing a statewide analysis of California. So we want to use the Albers, California projection here. So that's 3310. Great. So now that we have our data loaded into R, we're going to make a quick map that shows how pesticide use varies by tract across the state. So in our first line here, just setting some default styles for our maps. One thing to note is that the maps are plotting your information like on a plane. So it has like the axes and the grid. And for a chart, that can be nice. For a map, it's not so conventional, so we can omit that. And then basically style our title text. And then next we're gonna do our actual charting code. So as we walked through last week, if we're doing a chart or a map with ggplot, we start with that first call to ggplot. And then we're going to add a geographic layer with geom_sf. That is our Cal screen data. The important thing to note here is we create the aesthetic. Remember, that is like the vocab word for the kind of the way a particular like chart or map layer is going to look and behave. So we create an aesthetic and we say, we want you map to please color the tracks based on the percentile of pesticide use intensity for the tract. And then the scale fill distiller is one of those color brewer convenience functions that we talked about before. So if you dig into the documentation here, it can tell you more about your options, but the important things to note here are that we want shades of green to represent our intensity, and we want the direction to basically invert. So it defaults to having the lower values be darker and then the higher values are lighter. But for this particular map, I think it makes more sense for like the higher intensity to be a darker color. So that's how you invert your color scale. And then finally, we add the title. Like data tables, like summaries, a simple title and labels and, you know, a subtitle can be really helpful in interpreting the maps or other visualizations you put together. So that together is kind of how we're going to make this map. And what we get is this map. If you've looked at the Cal screen map, you will know this is pretty much identical to what is shown there. It does give you like kind of a high level sense of like, okay, like sort of Central Valley and into the middle of the state, there's a high density of pesticide use, but it doesn't give you a great look at like within that dark green block, how the intensity of pesticide use varies within those higher pesticide intensity places. So this can be good if you need that kind of high level view for your analysis. But if we really want to make the point about like where pesticides being used most intensely, we can make a version of this map that only shows, sorry, this says counties, but I mean tracks at or above the 75th percentile. So the top quarter of tracks by pesticide intensity. What that does is it basically allows R to spread those values across the full color scale, those higher values, instead of having to shove more values into that same size scale. So we can see more gradation within those higher pesticide using tracks. So the only difference between this code and the code that we're going to make is the code we're going to use to make the next map is that we have applied a filter to our data set, and we're only getting the tracks that have a pesticide percentile at or above 75. And then the other thing is on line 1, we're also just using like a base map with the light gray color to have like all the tracks in light gray, and then we layer on the highest intensity pesticide using tracks on top of that. That way they're not just like floating in space. If we didn't add our base map, the way we're applying our filter, it would just show us that little slice of high pesticide use tracks. But what this gives us now, you can see, is like a gray base map, and then that same kind of place that was previously all just a blob of dark green now has some variation in it. So you can see that there are definitely pockets of higher use and pockets of like lower relative use. I mean, we're still in the top quarter of pesticide use tracks, and that's important to remember. But if we really want to focus on like where is the highest intensity happening, the darker here is more instructional and helpful for us. And this is just both those maps side by side. I wouldn't say one is necessarily better than the other. It's really just like, as Anna said, it depends. Like, what are you, what story are you trying to tell? Who are you trying to tell it to? You know, are there other, in a minute, you'll see we're going to build on this map. So like what, what best lends itself to those additional layers or other elements that you want to include. Yeah, but that is a basic like choropleth that is already telling us, yeah, sure, there is some consolidation of pesticide use like in the state. Before we move on, are there any like questions about that?
Yeah,
Or-
there's one in the chat. How would this map compare to just where there's more agriculture? There aren't much pesticides shown in LA where there isn't much ag. And then someone else commented, urban pesticides are a thing. So I think for me, that question points out two things, that an additional complementary analysis might be this with the National Land Cover Database map, like side by side, to understand land use and pesticides, and also acknowledging that there might be a gap in our pesticide data if it doesn't capture urban pesticides. So I don't know, Hannah, if there's more that you want to add to answer the question in terms of how the map would compare, but all these questions are great in terms of like really thinking about the why behind why we're doing what we're doing and getting back to the root cause analysis of it all.
Yeah, totally. I actually don't know what that map would look like off the top of my head, but
Me neither.
I mentioned, you know, that is a great, like, that is a thread you would want to pursue to make sure that, like, that's an assumption, right, that we're making, that this is going to show us like all the pesticide use we need to know, and like maybe that's not the case. Or maybe we want to look specifically at urban agricultural use, you know, agriculture activity and pesticide use. So yeah, that's a really excellent question. It's great to see folks' brains already working in that kind of multi-dimensional kind of space. And also, like I said before, hearing you guys talk earlier, it's like, okay, this is kind of a basic example, but we just kind of wanted to get the foundations in place. So, right, we've mapped pesticide use. We've narrowed our map to show us the highest quarter of pesticide use intensity by tract. And so now we want to add that second thing we're interested in, which is failing water systems. So to do this, we're going to use the safer risk analysis data, risk assessment data, sorry. There's a link to it there at the bottom. And it's easy to work with because it's a flat CSV. So just a row for every drinking water system. So we can simply download it and then pass it to read CSV. And then we can, so just the plain CSV when we read it in is going to have, it's not going to be a geospatial data file, even though it has that long. Like R doesn't know it's enough to on its own be like, oh, these are points. I'll deal with that. So this next call will convert just our like basic CSV file to a geospatial file that we can use in our analysis. So ST as SF is the function, comes from the SF package, and you pass it in like whatever data you want to make geospatial. You specify which columns contain your coordinates, and then you specify a CRS. I think usually if you're using latitude and longitude, it's great to use 4326 because that is your kind of like point data projection. But you can see we've done that for this particular call. And then since we're going to be working with this in conjunction with the CES data, or the California Enviroscreen data, which we've projected 3310, we're going to also project this to 3310 so that we can do some joins and kind of match up the systems to the tracks. So from here, now that we've got our geospatial data, we can plot the location of our failing water systems on the map. So the first thing we're going to do is, like before, we'll add a light gray base map that just shows all the tracks. And to do that, we'll use our Cal Enviroscreen data, just say color everything light gray instead of colored based on pesticide use. And then we will add our geospatial safer data on top of that. So we're going to apply a filter here to make sure we're only plotting like the water systems that are failing. And then the other choice we're making here is to use alpha. So if you've never seen that before, alpha is like the opacity of a dot. So 1 is fully opaque. It's just the color it is. And a decreasing level is like more and more transparent. So like 0.5 is kind of in the middle between like 1 totally visible and 0, which is like totally transparent. But what this allows us to do, as you'll see, is where there are kind of overlapping points, you kind of get more of it creates sort of a heat map effect. So you can start to see like where there are multiple places in close proximity that are failing. There are lots of different ways you could make this map, and you could roll it up into like tracks, for example, and create a choropleth that way. You could make the points smaller or larger, otherwise subset them so they're not layering so much. There's like it just depends on what you're trying to communicate, but basically we want to see like, does the location of failing water systems kind of map onto where pesticide use is heaviest? So that's what we're going to do here. We are going to overlay those failing systems with our pesticide use and see if we start to see a relationship between the two. So to do that, this just mashes up code we've already written. So we have like our light gray base map that is all the tracks, and then we have the highest quarter of pesticide users on top of that with our green color scale. And then on top of that, we have our points with the alpha. And then we have a title on our theme. And that creates this map, which, as you can see, kind of starts to reveal a trend. Although, if if you're familiar with what colors are and aren't visible to someone who's got any variation of color blindness, red and green should stop you. This should be a record scratch moment where you look at this, you're like, if I'm not colorblind, I can see this, but there's a portion of the population that cannot. So we can ameliorate that problem pretty quickly. Just need to swap in the color palette we want to use for our colors, our scale, and then the color of our dots. So like blue and orange is a good one that's like pretty visible, but this would be a great place too, that you could use Color Brewer or another resource that kind of helps you make sure there's sufficient contrast for all like color vision to do this. And this is like one place where, so like the convenience functions, like the scale fill distiller and the Veritas things, like they're great if you're working with one layer, but you can like you can paint yourself into this corner if you're adding multiple layers and controlling the style. So it's definitely something to be aware of as you add more to a map, that you need to make sure like the visual relationship between the layers is legible. So that's the only difference, is we've swapped out the color schemes, and now we have the nice blue and orange version of this map, where the contrast between these two will be good, whether you can see color or not. So, right, we can start to see our relationship on the map. But this is kind of a vibes-based approach to it, just looking at the points, looking at the geographies and being like, yeah, I guess that's kind of lines up. So we're going to do a quick statistical analysis to see if there is a correlation between pesticide use and failing water systems. And to do that, we're first going to aggregate our SAFER data up to the track level, so we can compare at the track level. Does the percentile of pesticide use intensity have a relationship to the proportion of water systems within a tract that are failing? And the reason we're going to use the proportion of water systems instead of the count is that we don't really want it to be a population map. We just want to know, like, if there's more pesticide use, is there a higher occurrence, like, rate of failing water systems? So to do that, we can use a couple of functions from the tidyverse, which is sort of a suite of R packages that have a nice way of doing different like data operations. So we'll take, oh wait, I skipped over a whole thing, which is first we're actually going to do a spatial join between the geospatial safer data and the calovirus screen data. And so what that's going to give us is a record for every water system, and then each water system will have the information from virus screen that goes with the tract that system falls within. So tracts may repeat and will repeat here because there can be multiple water systems within a tract, but we're interested in the system level data, not the tract level data. That is one thing I would have you be cognizant of when you're doing data analysis is if you find yourself getting confused, think about like, what am I trying to count here? Do I want to know about the water systems or do I want to know about the tracts? And then that can help you figure like which way you want to do your join. Cool. So we do our join, which gives us a record for every water system, and then we are going to do a summary. So by tract, how many systems are there, how many of them are failing, and what proportion of them are failing. So to do that, we can use the group by function. From the tidyverse, you can give it the name of the column you want to group by. For us, that's tract. And then summarize is a way of adding these sort of like aggregated calculations to like your different groups. So for each tract, tell us how many systems, how many are failing, and then the percentage that are failing. And then finally, that's what we needed for the summary. And then what we ultimately need for our analysis is for each tract, the California virus screen data, and then that summary data. So we join our summary data back to our tract data, and then this will give us a record for every tract that has all of our calovirus screen values, as well as the number of water systems, the number of failing systems, and the proportion of systems that are failing. So that was a mouthful. Any questions on this before we look at the next thing? Silence. Okay, great. So next we'll perform the analysis. This is like a draw a rest of the horse type of thing. What we find is that there is kind of a weak positive correlation between agricultural pesticide or between pesticide use and like the prevalence of failing water systems within a tract. It's not, the the silver bullet, but there is, a small positive relationship there, and that's what correlation is gonna tell you. We also are calculating our R squared, which is basically an estimate of how much of like the change in occurrence of failing water systems is explained by the use of pesticides. So our R squared value is like 0.049, which it's a percentage. So it's about 5% of this like change in water system status can be attributed to pesticide use. So again, it's a small number. But if we look at our p-value, which is the likelihood that this like relationship would happen if there were no connection, is like basically 0. So we can have like a high confidence that there is some relationship here, but it's a small one. I think it's enough to kind of consider agriculture as sort of like or pesticide use as sort of like one determinant of failing water systems, but based on this analysis, you wouldn't be like, yes, this is the thing, we should pursue this, like, and really focus on just the agricultural places. And I think it really underscores, the reality that we live in, which is that it's, lots of things are happening all the time. And so like, I think it's going to be very rare that you'd have a factor that is like, and this explains 80% of like this change. I think you're way more likely to have relationships that are have a correlation, but are explaining a much smaller amount of the variation here. So this is the plug to check out the code on GitHub. We're not going to walk through the statistical analysis code here, but rest assured, it's like relatively simple, which is nice. R is very good and has a lot of stat stuff baked in. But yeah, it's going to be available on GitHub, and I'd be really curious to hear from folks after if you kind of get into this element of it.
Just before we move on, I just want to put a plug here as a reminder for statistically minded folks. Correlation does not mean causation. So there's 5% of the variability that can be explained by agriculture. I think this is really important, pointing to all of the other data sources and questions that you all have brought before of trying to understand the whole situation. So even if, the R squared was, 85% for those that have taken any statistical course in the last, 10 years, we've all seen the graph of like climate change versus pirates, right? Where the reduction, one could conclude if we mix correlation and causation, the decrease in the amount of pirates in the world has caused climate change. Like that's not real. So the data that we use really needs to be paired with our understanding of the lived experience of the community and the situation that the data represent. And it's just part of your suite of data analysis and communication tools. I just feel like I had to add that disclaimer because
I think
world.
That's so good. And it really kind of, what was I going to say? I think I'll leave it at there. I think that's a really great disclaimer. Oh yeah, what I was going to say is like I said, this is not like, it's very rare you're going to find something that is like, this is 100% of it. And also you can't be certain based on the thing, but it's great to start to kind of build like a body of evidence or a body of leads where you can kind of look at sort of different factors like the age of the well, or like where funding has happened, or like what the land use is, or like that sort of thing, and start to get some sense of like how strongly those things are correlated so that it can kind of give a shape to the conversations that you have with other folks, where you kind of can have some hypotheses of like, okay, the data suggests that like this is a pretty strong factor. Maybe I want to like interrogate that a little bit more. I want to get more perspective on that. You want to be careful that you don't like undermine like your line of questioning by like holding your hypotheses like too closely, but it can be really useful and like help if I had a finite amount of resources, I'm really going to focus like on the factors where I see like the highest or like the strongest relationship, and not try to cover like everything in the thing. I will also add, just based on, I went to journalism school and that's my original background, 15 years ago, but a great question to ask is there anything I'm not asking? And I would also encourage you to like take advantage of talking to real people who can answer that kind of question. It can really give you some surprising results, and very helpful results. Super. So that's our brief statistical analysis. We see there's some small correlation between pesticide use and failing water systems. And so we have this moment of like, okay, we know that there may be this relationship. What are some things we want to do here to help address this potential like mechanism? What do we have the authority to do? What can and can we not like address from where we're positioned at the water boards and within the water boards? Also, like an important part of that question is like, what is already happening? And that can be like, it's probably easiest to know what's happening, what is the water boards already doing here, but also like, what are other resources that sister agencies or other community groups are offering, that sort of thing. And then also like, based on those things, like, how do we want to operate within that landscape of existing like interventions and resources? Do we want to kind of offer like the wraparound service to kind of supercharge what's already being done, or do we want to try and fill the gaps that are left because resources are not infinite? Yeah, I guess do folks have like initial ideas or thoughts on any of these questions?
They don't have to be polished, complete thoughts. Just what's shaking around in your brains when you see this slide. And remember, I can out awkward you, and I can just call on people at random. So what do y'all think? Okay, pulling up the participants list. Who haven't we heard from? Whose voice am I missing in my life? Megan, what are your thoughts on this?
Like, well, I don't know, maybe have a permit where we can cap pesticide use. I don't know if the board members be okay with that, but I want that.
Awesome. It's an option. Something to consider. Let's see. Who else? Alex. Oh, there's two of you. Alex Lopez. What are your thoughts? Also, it's totally fair to say, I don't know, I need to think about it more. That's okay.
Well, we can move on though, Anna, if you want. I see
Oh, yeah.
Nick.
Go ahead, Nicholas.
Well, authority, I'm not sure, but so I'm in the Sigma office and I've been sitting in technical meetings with Kern. We have their probationary hearing coming up in September, and we've been pushing them to try to have these mitigation plans in place for groundwater quality. So, you know, if they get a hit on one of their monitoring wells, that they let everybody know in the surrounding area. Like I think we have like a 3-mile radius that they agreed to send out mailers, you know, to everyone that has domestic wells in that area, and to have some kind of mitigation plan in place, like that they would pay for like an RO system to be installed if they find that, you know, it was caused by a lowering of groundwater levels in the area. So I don't know if that fits in here, but that's kind of what came to mind.
Awesome. Thanks. All right, we can stop making it awkward for them and keep moving.
I think that's definitely like I think it's definitely fits right in. It's definitely like you're already doing it. So it's like a thing that's within the remit of the water boards to do, and you're already doing the hard work of getting the local folks on board with doing it. Some other things that you could consider is like we've been talking about SAFER this whole time. So it's like, well, yeah, SAFER's made quite a few investments around the state to kind of help mitigate water systems that are failing for one reason or another. So maybe we want to look at you know, where they're working and try to plug some of the gaps left behind. So let's walk through how we might approach that question. So plugging the gaps, we want to find the places that haven't received SAFER funding. And we want to target those places specifically within the tracts where we have a high level of pesticide use. So a way we can get at that is take our data that we made that has a record for every water system and filter it. A record for every water system that we joined to the CES data. So we have both our water system info as well as the California virus screen data. And then we can apply a fairly simple filter. So we want water systems that are failing. We want water systems that haven't received funding since 2017, which is like the field we have from the latest risk assessment data. And then we want systems that are located within a tract that has 50%, or is at the 50th or higher percentile of pesticide use intensity. I love that Tidyverse makes it so simple to do that sort of thing. The next thing we'll do is like, if you look at the data, like the SAFER data has a bunch of fields and the common virus screen data has a bunch of fields. And so we're going to make a table here really quick before we work more with this data. And so when I'm making a table, I try to think about like what information is going to be like glanceable and useful to kind of like a quick interpretation of what's going on here. So I picked a few things. There's definitely more you could pick, but we've got the water system number, the city that's associated with the water system, the population served by that water system, as well as the service connections to that water system, the funding received if you use as a filter, the the service area, so economic status, which is really nice. So they'll tell you if they're a disadvantaged community or severely disadvantaged community. So maybe that's useful. And then also the pesticide percentile. So we have that as context. And then we can do that with the select function from the Tidyverse. It's this function select, and then you just put in the name of each column you want. And then arrange is nice. So this is how you sort your data for display. I almost always, like if I'm making a table, I'm going to show people, I'm going to sort it in some way. It could be simple, like alphabetical or like in ascending water system number order, that's fine. For the purposes of this, since we're trying to think about like, oh, what might be a place that we could dig into and potentially provide resources to, I was like, maybe we'll look at like where the most people are using that water system. Maybe that's a pretty simple like way to sort the data. So we can use the arrange function to sort by any of the columns. And then it's important to note by default, what you pass into a range is going to sort an ascending value. So it would be like the smallest population to the largest, which is probably like the opposite of if we were going to prioritize based on population, how we want to see the data. So if you do descending and then your column name inside of that, it will invert that value. And so what you then get is this like nice table. So you've got your city name. You can see like there's definitely a couple of places in here that have 10 or more thousand people that have no money from SAFER as of yet. And then you can see too, 4 out of our top 5 most populous places are disadvantaged or severely disadvantaged. And you can also see here, like there's a couple like upwards of 80 percentile of pesticide use intensity. So this could be like a good starting point to start to think about, oh, maybe these are places that could benefit from some sort of intervention. You know, if it's not funding from SAFER, maybe it is the notification system that Nicholas was telling us about, or some other kind of intervention to kind of help mitigate the harm, even if we can't fix the system right away. Yeah, and I saw you come off mute.
Another thought I had is having these sorts of data and information can inform how we prioritize our engagement efforts. So like, yes, there's the communication system, but if we're thinking about wanting to engage with these communities to understand their lived experience and what they see as the needs are for their communities, maybe we could, like, again, resources are not infinite, unfortunately. So there's only so many of us, we can only go so many places. So this can also inform not just like the potential solutions, but who we might pull into our community expert panels or engagement priorities as well.
Totally. The last thing I'll call out here is that, like I mentioned, there's a bunch of like population characteristics like in both the SAFER and California EnviroScreen data, which you'll have together at this point in the R file. So I definitely encourage, if you're looking for like a learning exercise, like play around a little bit. There's all kinds of like ways you could segment this data and slice and dice this data. And you bring a lot more a lot more subject matter expertise and like working context to this. So I would be really curious to see like how folks would work with this data. Yeah, cool. And then the last thing we're gonna do is I wanted to show you one more kind of map, just to kind of have another tool in your toolkit. So we talked about point maps, which can be helpful in kind of giving you a distribution, but if you want to start to think about some of the differences between what you're plotting, it's not always readily apparent from just looking at a bunch of red dots on a map. So we're going to make a bubble map, which is where your point is like scaled to a particular value to show the location of these like candidate water systems that we found, as well as how populous they are, so we can start to get a sense of like where are the most people living within our like candidate system service areas. So the first thing we're going to do is, because I know this because I looked at the data, we wouldn't know this based on the analysis, but you can like look at your data values like in RStudio, and there's like kind of a bunch of these systems, as you might expect, are smaller places. So there's like a lot of values below like 5,000, 2,500. And so if you use the default kind of like bins that R wants to put your data into, you'll get like a bunch of very small values and then like a couple of very large values, but not a whole lot of nuance in between. So if you have data like that, there are ways of like programmatic ways you can say like calculate bins that have like equal numbers of things in them, or calculate like other slice this data in a way that I can see the thing better. For this data, I kind of eyeballed it and picked like an ascending scale, but that like jumps by different orders of magnitude along the way. So we refer to them as breaks, but it's basically just the intervals of data. So 0 to 1,000 to 2,500 to 5,000 to 10,000 to like 20,000. So that's the first thing we're going to do here, and the reason that we did it. The second one is that we are I'm going to show you. So earlier when we plotted the points, we plotted them as a geographic layer. When you try to do that and you want to scale your points based on a value, R is like, no. So like the more reliable way to do that is to use this geom point method, and you have to pass it data that has Latin long in it. And so our candidate system data, if you remember, is not going to have that original lat long because it's like a summary joined to another thing. So anyway, we have to add back our original safer data so that we have the lat long that we can use to plot our points, so that we can use the aesthetic that's going to size the points based on the population. So it's sort of circuitous here a little bit, but it does give us good practice. So if you were writing this, and if you're me, you might spend some time being like, why is my base map like not showing under my point map? And it's because like our CES data, if you remember, is in the California Albers projection, and we're using the lat long projection for our points. So this is one thing R will not break. It will just give you a really confusing map. You're like, why are all my points in one place on my track map? That doesn't make any sense. So that to say, be mindful of what you're plotting and then try like project your layers accordingly. So we're going to take our Calendar screen data, turn it into the point projection, and then we're going to take our candidate water system data, join it back to the data that has latitude and longitude, and then we're going to create our aesthetic. So we're going to size the points based on the population. We're also going to color them based on population range. I find that, especially if I'm just doing the points on a map, it's really nice to have that variable encoded both ways so it's more glanceable. Circles in particular, people aren't very good at like interpreting like variation in size of them. It's just like not the way our brains work. So I kind of like to have both heuristics there so it's easier to interpret when we're glancing. The other thing, and we talked, I've been talking about these bins, but that's another choice that we've made here to make this more legible. So we could have like a continuously sized scale that like is gonna scale like 1,000 and 1,200 differently, but we've chosen to do like buckets or bins of values, and then that way we can like plot a range of values like as the same size. That can be really helpful in interpreting, having like kind of concretely sized buckets versus having like a bunch of points and literally none of them are the exact same size. And then similarly with the colors, we're also doing binning there instead of a color scale like we've done. That way it is actually like 5 different colors and not like 5 different shades of blue where you're like, is this one, that one? I don't know. But that's another choice. So we've made with color here, and that's available to you too. Okay, cool. So we've done our geographic layers, and then we're going to use our convenience function, the scale fill fermenter, to generate a nice like color palette. Can kind of make out the palette we've chosen. It's going to go from yellow to green to blue, just to make sure that there's like a real kind of contrast between the different sizes, and it's not just all like shades of green or blue. And then I wanted to show you how you can like combine. By default, if you did this, it would create 2 legends, one that has the differently sized points and one that has the different colors. But because like those are both encoding of the same variable, we want them to be in like one combined legend. And so the way that you do that is make sure that both of your like aesthetic functions are named the same thing. And then you also pass it in like the same kind of like legend object. And then R can interpret this as like, okay, like she wants that to be condensed into one thing instead of in 2. I learned that this morning actually, so that's how you do it. And then, yeah, that's overall, this is all the code you need to make kind of a bubble map. And so what that ends up looking like is like this little guy here. So you can see we've got our like scale here on the side that combines both color and size of the dots. And then we can see on our map, there are definitely some like some places that are a lot more populous, and then a bunch of like really small places, or a lot of water systems that serve a small population, and then a few water systems that serve larger populations. But yeah, that's really it. I guess the point we want to make here is like once we've identified the candidate water systems, you always have the option of like repeating that initial, or we talked about like how you might prioritize them, right? Based on population. You might want to add that additional element of like, do I want to prioritize the places where it's not just like the number of people, but like the characteristics of those people, whether it's race, ethnicity, whether it's a raw number or like the proportion exposure, that sort of thing. But like you could write like a function in R that takes some arguments basically, that's like the place and the county, and you could have it repeat that initial analysis we did that'll tell you like the number and proportion of people by like race, ethnicity, or whatever. You could also add like census variables as like a parameter. And so maybe you want to vary it, and you want to look and see like how your results change if you look at like race, ethnicity versus like different income bands or like these sorts of things. That's where like the reproducibility like really comes in and can help you, because it lets you try out a lot of different things quickly. It lets you combine things quickly, and it kind of helps you go through that trial and error and refinement process that is, data analysis, but also, all the resource allocation decisions and other decisions you have, the administrative decisions you'll have to make on a daily basis. Makes it a lot faster and a lot easier, so you can get off your computer and actually like do the work. Yeah, I think like you could do that. You may find a dozen places that look the same as Lamont, like on paper. So you can prioritize where you see like the same kind of racial disparity or any other kind of disparity that is important, or could be important to the mechanism or to the intervention you're interested in implementing. And then again, we're going back to like, you really, can form some hypotheses based on what you see from the data, but you really want to validate or invalidate those hypotheses based on conversations you're having with the actual community, with like the local governments, with community groups, with residents. So what this kind of gives you, and this is going to be frustrating, but it's like a starting point, right? It's not the answer, but it is a direction that you'll then pursue, the way you know how to pursue it. Yeah, so we're really in a place that's kind of a wrap up now. I'm curious, like based on what we've seen, I think folks have already shared some really great ideas of like alternate data sources, as well as like additional questions that have come up, like the urban pesticide use and that sort of thing. Like, is there anything that stands out to folks as, are we missing something? Are we making assumptions we need to challenge? What kind of next steps crop up for you guys?
Maybe to refine that and make it a little bit easier, what would you do next in your analysis process? You got to here. Now, where would you go?
If no one else has something to add, I have an idea. I'll say this. These two workshops have been, I guess, empowering. Giving me some tools that I can then use in my own work. Although I don't anticipate looking at pollution at this moment. I want to look at where my unit's projects have been implemented, and really see the demographics of the surrounding areas that those projects are in, and seeing what the impact of those projects has been. So that's kind of what I want to use. So thank you. All this mapping code is very, very helpful for me. Thanks.
Awesome. We have someone in the chat saying maybe explore another question around why the water systems are failing. They probably don't all have 1, 2, 3 TCP and arsenic. So like what other pollutants should we care about? Should we consider? I think just for me, and circling back to conversations we had, getting a better understanding of land use overall. Like maybe that's something we should explore more.
Totally. And like the age of like wells and like the groundwater levels and other things people have brought up too. It's a great way to kind of.
Yeah. Other things coming into the chat. I'd like to run the same code with various data sources to replicate and to validate the results. Are you getting the same results or approximately the same results with different data sources? Someone else says, I'd love to run some multivariate regressions, including other contributing factors like race, income, etc., and see how much those explain the failing water systems. Awesome.
Totally. That's a great way to check some of the feelings people had about, it's a largely Hispanic population. People probably weren't looking out for them. Like that's almost certainly borne out in the data as well. And especially if you're dealing with an audience that maybe isn't as intellectually generous as this group, having the numeric support can be really helpful. Oh, that's a great point in the chat, especially for the areas we're looking at. We're assuming a permanent population rather than like a seasonal population, which could affect outreach. That's a really great point.
I'm glad to see the brains are churning. For the sake of time, I think we should keep moving.
Totally.
But I love these questions.
Me too. All right, so yeah, we're kind of in the wrap up phase, and a few like parting thoughts here that, there's a lot of wrong ways to do this, but there's also a lot of right ways. I think, Anna, you phrasing it as like, there's no one right way, but I'll make it just seem less scary. You can do this in a lot of right ways. It's not a linear path. It's a practice, right? And it's something that you work on over time. It's something you'll refine as you're looking at, the same questions. It's something you'll refine as you do this over time. But yeah, I was, Luke, I'm glad to hear you say you found it empowering. I'm kind of like the hope here was that it gives you the foundation to build from. Yeah, and I guess the other thing I would just underscore is that I'm sorry I have to leave you at like, we don't know the answers. We have some questions we want to explore. But this is definitely like a process that is really benefits from engaging with community, partnering with other folks, whether it's other organizations, other teams at the water boards, all types of, kind of better together types of work. It really helps to make sure that the data, what you're seeing in the data is kind of borne out in reality. Because if we talked about like data isn't people, data is not lived experience, and there are things, you have to make assumptions when you're using data, which is, in essence, an abstraction, right? And so you have to make sure that what you found is actually reflective of people's reality. It also, better together, it helps us address a problem holistically and not just the water-shaped parts of it. And in doing that, we can really get at full root causes of problems, or get at a root cause from assorted angles, which kind of improves the likelihood that we're going to make some impact on changing it. So yeah, I think that's really the end here. Anna and I put together a link of like additional resources here. So to the GitHub module or to the GitHub repository, there's like a little site with links to both modules. There's also a link here to the Equity Data Handbook, which if you haven't seen it yet, it's an excellent resource. It's got all kinds of things from, what is a root cause analysis to like, what are the design considerations I should use when I'm talking about, what I see in my data. And then Anna, I'll let you talk about these next two.
Yeah, just a reminder, you're not in this alone. You might feel isolated if you're like the only data scientist or data nerd in your unit. I say that with love, just so we know. Really tap into the communities at the Water Board, the Environmental Justice Roundtable Equity Data Subcommittee. You're all either part of it already, but if you're watching the recording and you're not part of it, join us. There's the chat community I talked about in the email. And last, there's a feedback survey. No training is perfect, and we want ideas for future trainings and how to better continue to support you all as you do this really important work. I added a link to the chat. The survey will take probably 5 minutes or less, depending on how communicative you would like to be for us with us. And constructive criticism is welcome. We can't improve if you don't flag challenges that you've experienced over the last couple modules or just like in your work in general. So if you can complete that by like this Friday, we're going to be debriefing next week and thinking about next steps. So we'd love to include your thoughts and feedback during those discussions. And with that, we've got 5 minutes left. You're welcome to turn your camera off and take that survey now. We can also hang around and have a broader discussion if people have conversations or questions that you want to bring up. I know, Danya, I said, we'll circle back to your question at the end. So I'm wondering, how you're feeling and if you have a revision to the question that you brought up early on in the what is this called? Training today. And if y'all are done, then you can just leave the Zoom. You don't have to stay here for the next 5 minutes if you don't want to. But Hannah and I will hang around if folks have questions, and I'm going to stop the recording. So see you around. Thanks for joining us. Happy data analyzing.